which molecule is a meso compound? So a meso compound first needs to have a chiral center, but its plane of symmetry makes it achiral. And the symmetry, especially in a cyclic compound, it has to be substituents that are in the cis direction. So first, let's look for our chiral centers. So a chiral center means a carbon has to have 4 different groups. And here, this is not a chiral center, so it cannot be V. And here, this is not a chiral center because it's bonded to 2 of the same groups. What about 1? There is a chiral center, there are 2 chiral centers, so then we think, is there a plane of symmetry? If we divide this in half, there is no symmetry because one side is fluorine, the other side is OH. So then what about 2? Is there chiral centers? Yes, there are chiral centers. One single bonded carbon bonded to 4 different groups. Now, is there symmetry? It looks like there is symmetry, but the issue here is that fluorine are in trans position, so this is not a meso compound. As for 3, are there chiral centers? There needs to be a carbon that's bonded to 4 different groups. Yes, there is a chiral center. Is there symmetry? Here, this is a tricky part. You might think, hey, I think there's a line of symmetry if I draw it like this, but this is incorrect because in reality you can't be dividing the fluorine by half. So then here it's actually bonded to H, and then you'll see that there's no symmetry because one side has fluorine and the other side have hydrogen. So 3 is not 3 does not have an internal symmetry. So 2 is not a meso compound either because it's a symmetry, but it's not cis, it's trans. So the answer is none of these choices is a meso compound.